Hi, I'm Andrew. Welcome back to Sanctuary Domes, home of the Aero Grow. And on this channel, wait, I have to read this. I'm still memorizing this. My newfound mission statement here. On this channel, I bring real-world manufacturing strategies to your DIY projects, helping take whatever DIY project you're working on to the next level. There it is. That's my statement. All right, Sanctuary Domes, home of the Aero Grow. On this channel, I bring real-world manufacturing strategies to your DIY projects and help take whatever DIY project you're working on to the next level. That's what it is. That's what it's about. But if you're here today, you're probably here to talk about tapping threads into 3D printed parts. Now, the reason I know that people are talking about this is, although I don't have a lot of views on videos so far on the channel, I can see that the most viewed video is the one about tapping threads in 3D printed parts. So unfortunately, that was kind of a rush job. When I made that video, I was in the middle of some R&D, just, you know, the usual. And I didn't really put a whole lot of time into that video, but since everybody seems to want to talk about threads, I figured I'd go into a bit more detail about that today. Now, in addition to talking about tapping threads into 3D printed parts such as this one, is a big chunky part. This is probably the chunkiest part on the Aero Grow system. It holds a motor. It's a motor mount. Yeah, long story. Anyway, there are a variety of holes on this piece that I need to tap regularly. One of them is a 4mm and the other two are 6mm. And I'm going to show you a bit about that today and talk about that. But in addition, because a lot of people, well, with the Aero Grow, I should say it this way, with the Aero Grow system, it is a combination of 3D printed plastic parts and also PVC parts. So it's a blending of the two together. That's really kind of the beauty and the magic that is about to be revealed in an upcoming video, but I can't talk too much about the complete machine that is called the Aero Grow. But what I can tell you is I use PVC and I use 3D printed parts. Both of them are tapped at one point or another. The 3D printed parts are tapped because I need to put screws into them. And we're going to talk about metric versus standard just a little bit. I'm not going to get on my soapbox about that, but really it does become important when you start designing parts for 3D because you're ordering parts from a world that really doesn't understand standard measurements like 3/8 of an inch, 1/2 of an inch, you know, 3/4, 11/16, 11/64, all these crazy American standard deviations of an inch that that we use here in America, but the rest of the world uses metrics, right? So absolutely all of the screws and nuts and washers and everything else that and taps and everything is all metric, right? And the little fittings for air hoses and things like that, all metric, right? So I don't know where the current status of our society here in America is with the metric system. I know that when I was a kid, there was a big kind of battle back and forth, and there was an initiative, kind of a push to introduce the metric system to American kids because it was the system of science and so forth. I don't know if it really ever took. I think a lot of our foods are still measured in gallons and pints and quarts and weird ways like that. But some things like are measured in metrics like medications and anything in science, anything in the world of science is going to be in metrics. Anything that you're ordering online directly from China, for example, like little screws and nuts and bolts and what have you, they're all going to be M3, M4, M5. That's metric, 3mm, 4mm, 5mm. That's what that means. And they're all going to be sold that way. So that's what you're going to want to be looking for. Now, in the case of the Aero Grow, because there are PVC parts that are also being drilled and tapped and used, the reason for that is because there's, for example, one piece of the system has been turned into an air tank. So there are a couple of PVC tubes and fittings, and it's just kind of a long, maybe 4-foot long piece. There I go using standard again, 4 feet long. I actually do everything in metrics. I slip sometimes when I talk to other people because I know that most people are used to talking in American standard. In fact, all the pieces for the AeroGrow and the domes and everything, it's all done in metrics. So anyway, I digress. All of the little bits and pieces that are used to make this air tank made out of PVC, such as these little air fittings, that fit, by the way, 6mm tube, right? So I mean, here we go again, metrics, metrics everywhere. And then we have, now, it's going to sound weird when I say this, but yeah, it's a 6mm tube, but because this is measured in what's called NPT, which is National Pipe Thread Standard, the threads on this part, even though the hose, the tubing is 6mm, the threads on the part itself that goes into the side of the PVC here is measured in American standard because it's an American-made part. It's being sold to Americans, made in America. It's our system. NPT is our measurement system. So you've got a blending here. This is very common. You have a blending of an American standard measurement for the threads of the part and a metric fitting for the standard 6mm air hose that you find in hydroponics and aeroponics, right? So it's a blending of the two worlds in this one part. I didn't expect I was going to explain that part today, but there it is. So so here we go. The world expands here in this video. The world of threads. Okay, you've got two basic things going on here on this table. You have two needs. I have the need for putting threads in 3D printed parts so that I can put screws into them. Just let that sit there. There are no threads in that at the moment. I'm balancing it. And then I have the need to put the threads in the PVC so that I can have air fittings and actually other things too, such as, like gauges like that, like an air gauge like that goes into, here's a pre-tapped piece, right? Just like that. All right, boom, Bob's your uncle, right? So actually, this is a really complicated piece in the AeroGrow system, which you'll see in a couple of weeks. This piece has, oh man, it has an air control valve on it, 12-volt air control valve, electrical valve that shuts off when the air reaches 100 pounds per square inch. That gets plugged into this over here, right? And then you've got, oh man, yeah, you've got the gauge right there. And then you have, now I never actually drilled the additional 2 holes here, but then you have 2 more holes for 1/4-inch air fittings, 1/4-inch NPT air fittings, right? That's a description of the threads. That's a description of the part itself is 1/4-inch NPT, which opens up an entirely other conversation I'm not even going to get into today, but suffice to say that NPT, National Pipe Thread Fittings, which can be, 1/4-inch or they can be 1/2-inch, right? They can be a little bit smaller than that too. You have, this is the 1/4-inch, and then you also have these 1/8-inch NPT fittings. Hopefully you can see that on camera, I'm not quite sure. 1/8-inch NPT, 1/4-inch NPT, 1/2-inch NPT. Again, description of the thread end, not the hose end. They all fit 6mm hose, but they're different thread sizes, 1/4, 1/8, 1/4, and 1/2. Then for those 3 sizes, you have 1/8-inch NPT, an 1/8-inch NPT tap. These are the little threads on there to tap the hole, right, after you've pre-drilled it. Then you have 1/4-inch, and then let's see if I can do this on camera and not look like a complete moron. And then we have 1/8-inch, 1/2-inch. Still looked like a complete moron. Okay, 1/8-inch, 1/4-inch, and 1/2-inch taps, right, for 1/8-inch, 1/4-inch, 1/2-inch threaded air fittings, okay? That's NPT, National Pipe Thread. All right, that's one world. That's a whole world. That's a whole microcosm right there, all right? So if you need to drill those holes, that's what you do. Now, when you buy a set of these, all right, there's probably going to be also included some drills, the appropriate size drill bit for whatever size tap you're about to use, right? Now, what's funky about that is that they're very, very specific, because if you think about it, when you drill the hole to then follow it with a tap, you're really just drilling the hole so that it's big enough that it's just inside of where those little cutting blades reach out. So the little fingers of the cutting blades are going inside and cutting threads, right? So the drill, when you drill the hole beforehand, it needs to come just to the edge of where those threads are going to be, so that when you chase the hole with the cutter, there's something to actually cut. And then when your threads are formed, they have a nice perfect shape, the shape that was intended, because the material is all there. So you don't want extra material to obstruct your path. That's what you're drilling out. You're drilling out to remove the material, to open up your path, to allow the cutting blades to have free passage through the hole, right? So you want the material to stay so it can be cut, but you don't want it to get in the way. Now, that being said, they know, the infamous they who develops these cutting tools, knows that there is a certain amount of material that's going to need to be evacuated from that channel that you're cutting through, which is why these are fluted, right, on the side. So these are fluted to allow that material to escape out of the hole. But still, in good practice and in standard practices, as you're tapping, and we'll go through that in the demo at the end here, you still want to go slowly, back out, allow the material to come out, and then proceed forward. You don't want to just go full force jamming through there, because you're likely to booger up your threads, especially when you're working with plastic. You want to be very careful, go slowly, and you want that material to be removed as you go, right? Okay, NPT, that's one thing. The other world was, again, tapping into the 3D printed parts, where we're in metrics now. We're in the metrics world. We're working in M. I talked about in the other video, I did talk about how you really don't want to go smaller than about M3 with 3D printed parts, just because with an M3, let's see if I can find, I think this is an M3. With an M3, you're talking about, yeah, it is very, very small threads on that. In fact, I don't think I might have an M3 here. Let's see. So, I mean, we're talking about a 3D printed part with a 3D printed hole that's about to be tapped for an M3 screw, right? So there's your tap, and there's the screw that's going to go in there afterwards, right? Same diameter, right? So your hole, of course, to do the M3 is, yeah, you're going to want it to be about, I would say, a little under 2 millimeters, yeah? So when you're in your software, usually you're doing half the diameter, right? So if it's a 2 millimeter hole you're looking for in your final print, then you're gonna want to go 1 millimeter over when you're dragging your circle, and that makes a 2 millimeter hole in your software, depending on your software. But ultimately, you'd want a 2 millimeter hole to print for you. And then that would leave an extra amount of material for the threads to bite into, so that when you're all done, it would fit that 3 millimeter screw, if that makes sense. Hopefully that made sense. But I would not go smaller than that, certainly not with 3D printed parts. The reason being that when you get, the smaller you get in manufacturing, the smaller you get with something like tapping threads is a really good example. The more precise you have to be, the less likely you're going to be able to achieve that level of precision in something gummy and sticky and flexible like plastic, right? I mean, you could definitely tap way smaller threads, even than these here, into the fractions of a millimeter, if you're going into steel or even possibly aluminum down to a certain point. Aluminum's pretty soft too. You wouldn't want to go too far with that. But yeah, you could go pretty small even with aluminum. But you don't want to push it. So with this material, I was recommending that M3 or 3 millimeter was as small as you want to go. Now, once you're in this world, I have a really exciting new product I want to tell you about. I don't know if it's a new product, but it's new to me. That I talked about in the other video, but I didn't actually have it yet. It was on order and it had not arrived. And that is a kit of these combination drill taps that are two things going on here. There's typically, of course, just to review really quickly in case you're new to drilling and tapping, typically when you tap a hole, you pre-drill it with the drill, like with the NPTs, pre-drill with the drill, and then you follow it with the tap, and then that's your process. And then you back out, maybe do it again to clean up your threads. However, with this new one, new to me, the drill is on the end here, and then your taps are right behind it, right? So you just pop this in your drill, and we're going to actually demonstrate this in a bit, but pop that in there, and it's all these standard, six-sided bits that fit really well in the drill, and they grip really well, right? Keep it on a slow speed, right? And then you just drill. You go slowly. Of course, you always go slowly with these things. You don't want to go hellfire all through there. You just make a mess. So you go very slowly, and then as soon as that hole is drilled, the taps are right there ready to go. And you kind of get a feel for it after a while. You feel like, oh yeah, okay, the drilling part's done, and now it's a little resistance. I feel the taps cutting, and then you slow down, you back out, clean off your material, and then we'll demonstrate that. But anyway, these new ones are really, really cool. It was a full set of all the common sizes that I use here for 3D printing, from M3, M4, all the way through, well, let's see, I think it's M7, I think is it might be M6, I think is the largest here. Yep, M6. M6, so M2, 3, 4, 5, 6. All of them are included in that kit. And I think the kit was, I'll see if I can put a link in this video down below for you, but I think it was about $15 or something like that. And because I'm only using them dedicated for the plastics, I think they're going to last a long time, because it's kind of gooey and sticky, but it's not harder than the metal. So I think the metal's probably going to last a long time. Stay nice and sharp for me. So those are the two worlds that I live in here with drilling these holes. Now, what else can I talk about before I move on to, let's see here, getting the outline right. Okay, yeah, one more note here. Okay, so in the other video, we also talked about how when you're pre-drilling your holes in these parts, or I did it again, I always say pre-drill. When you're pre-printing your hole in a 3D printed part, and again, you're going a little under what you want for your final size. So if I want, yeah, that was a 6. This is supposed to fit a 6 millimeter screw. So I printed it a little under 5. It was about 4.5 millimeter. And as you can see, it's like still working to even like go in that hole. There's material there that it's working against. So I know that that's where I want to be. That's about right. You want to be able to kind of, this is kind of a good gauge if you want to go by that. Take your bit, and if you can get it to kind of stand on its own, but you can't do much more than that, that's perfect. Then you have a little bit of resistance going in there, but not too much, but enough that you can actually get it to stand on its own. That's good. That's perfect. So I would say that's your guide, right? If you're in an R&D phase and you're trying to figure out what size do I want to print the hole so that the bit's going to fit right in the end, that would kind of be a way to gauge it, right? Okay. Again, that's R&D. So yeah, that's how that works. Okay, so here's another thing. When you are, and this is for the hydroponics people, aeroponics people who are working with a lot of PVC, and you want to tap into PVC, many of the principles are exactly the same. In fact, really identical. The only thing I've noticed that's ever really different is that when you're doing the PVC, you tend to be, it depends how you design your parts, I guess, but I tend to be drilling through a lot more plastic than I would be with a 3D printed part, because I'm designing the 3D printed part ahead of time, and I'm intentionally not making my holes that deep because I know I'm just going to pop a thread into it at the end. But with PVC, I've got the wall thickness of 2 pieces of pipe. And that adds up. I mean, and sometimes I guess in the future there may be even more than that. I'm not sure where I'm going to go with it, but for now I've got 2 wall thicknesses. But the reason I have in this case doubled it up is because this is a critical part. This part sits on an air chassis, on an air chassis. Sounds like I'm building an airplane. It sits on the air storage chassis, which 4 pieces of pipe and so forth. But this piece, of course, fits all the gizmos and gadgets. It has the air fittings. It has, the automatic shutoff valve, the 12-volt automatic shutoff valve sits on this piece. The regulator. Now it sounds like I'm scuba diving. Yeah, the air gauge here sits on top. So a lot of stuff is going on with this piece. So when I've made my first couple of iterations and tapped the holes and put all the pieces in and glued the whole thing back together and pumped it full of air, I noticed that I was getting a lot of leaking through these fittings. They were tapped, you know, I tapped them correctly, I knew that. And I followed the tapping by wrapping the threads with one wrap of, or maybe two, I think, 2 wraps of Teflon tape, the good stuff, the blue stuff, and then following that with some thread sealant, liquid thread sealant from a bottle, and then screwing that in. And I was, in some cases, still getting some leaking. And I discovered later the reason that leaking was happening was because you really get one shot at putting your gizmo or gadget into your tapped threaded holes in a plastic part if you want it to be airtight. You get one shot because the threads on these NPT fittings are designed in a very specific way so that they bulge out as you thread this piece in, so that it compresses against the threads. It's designed that way to create airtightness, right? With the help from your friends, with a little bit of tape and thread sealant, usually you'll get a really good seal. It threads out towards the middle of this thread run, bulbs out. But then it goes back in again. Then the threads go back in again. So I didn't know that. So I was threading this thing in, and then I kept on going, thinking, oh, tighter's better. Went tight, but by the time you get to the tight part here, you're on the narrow part of the threads again, right? So I was creating air leaks. So I'm like, wow, what am I going to do here? I want to make this so that it's not so critical. I want to make it so that I can kind of get it tight, but also still have air tightness, which means I needed more material. I literally needed what I now do have with this. I have 2 wall thicknesses here, which gives me all the meat that I need to bite into when I start threading this in. So it worked out great, but the thing is, you have to keep in mind that this is sticky and it warms up, and there's a lot of friction, and as soon as those threads start getting cut and your bit heats up, there's more resistance because now it's hot and trying to go through the plastic, so it kind of gets like the nozzle on your printer. It heats up and gets gooey, and that makes it difficult. So you have to really kind of take your time, back out, remove the material, even let it cool down. A couple of times when I was drilling these threads, for whatever reason, I could just tell that there was a lot of resistance, so I would back it out and then feel the bit, and the bit's really warm, after just going about halfway through. So you just let it cool down a little bit, take off those chunks. Oh, another thing is, sometimes when you're doing the initial drilling of the hole so that you can then follow with the tap, especially in plastic, when it gets gooey and soft and you have a nice sharp bit, sometimes a sharp bit will work against you a little bit in that it'll cut so quick, so fast, and so far that it'll actually create big swirls of plastic, which are then firmly stuck to your part, and you can't get the final cut to happen because if that makes sense. So instead of putting the drill in and drilling a clean hole through, you get halfway through and it stops, and then you've got these big curly Q plastics, kind of sticking out here, and they're not going anywhere, and you can't get the drill to cut them off. So what I eventually did, because that kept happening, is to prevent boogering up the holes on the other side when it finally does go through, I used a piece of metal. Where'd it go? Here it is. And you take this piece of metal. This is round, flat stock, just a piece of, here, I shall demonstrate. Just a piece of steel. And what you do is you put that in your tube, right? And then when you have your drill bit in here, and you're drilling, you hit against the steel plate instead of going through the other side and boogering up the threads on the other side, or worse yet, going through your hand. Or, lots of bad things can happen when you do this kind of stuff, as you know, DIYer. But yeah, you want to have that metal plate in there to act as your backing plate. That's a really kind of top tip of the day if you're drilling in plastic bits like this. But aeroponics people, hydroponics people, that's a good tip for you. Let's see here. What else can I show you? So, well, let me talk. Geez, I don't have that stuff here. Well, you know what? As far as putting the tape around and the thread sealant, let me know in the comments if you want me to go into that. I can do a demonstration where I actually literally will wrap and seal and, you know, plug everything up, and then we can do an air test and pressure test it or whatever you want. Let me know. But this system, as designed for the aeroponics unit, is designed to safely hold 100 psi in the drilled and tapped parts that are all part of this air storage system. So 100 psi all the time, and then the aeroponics portion of this runs at 40 psi to the aeroponics fogger head. That's a whole other thing. We can talk about that later too. But doing it this way does get you 100 psi storage as an air storage device in your PVC. There are other things about PVC too that I've run into in the building of these machines for growing at home that we can talk about in other videos, having to do with ways of sealing these pieces together so they look a little better. They don't look like plumbing pieces. Also, where to source your pieces so they do have a little more stability. PVC bits and pieces, the elbows and joints and T-fittings and 45-degree fittings and all of those. All of those can be had at any box store, but some of them are nicer than others, as I've discovered. So we can cover that too, but just let me know what you want to see. Let's see here. So let's do a little demonstration. A demonstration. Let's see here. What do we have? We have 4 millimeters. So, okay, here's another thing. So I've got a screw here. Let's say I don't know what size it is. I think it's 5 millimeter, but let's say I don't know what size, and I have my calipers because I'm pretty sure I was born with these in my hand. You know, I'd have to ask my mother. Yeah, you take your calipers, you set them for millimeters because we're working with a millimeter screw. And the way you want to measure on this little girl here is you just want to do that, right? You just want to put it between the teeth, right? Like that, right? Squeeze it down so that it holds it on its own, just like that, right in the middle. And I see that we have, whoops, I'm setting on inches. That's not going to help me. Yep, 5 millimeter. So here's another thing we can talk about. What my calipers are actually telling me right now is that this is 4.79 millimeters. Now, I happen to know this is a 5 millimeter piece here because it came right out of my kit. So I know that's a 5. But let me take another sample here and I'll show you something really kind of interesting. So this is supposedly a 4, but it's not. It's 3.74 by the caliper, right? But it's a 4 millimeter, right? What you will find in the world of manufacturing, in the world of metrics, in the world of measurements of hardware and tooling, is that your tools are always exactly what they say they are. If it's whether it's a 6 millimeter drill bit or it's a 1/4 inch drill bit, it's going to be exactly that because it's a tool, it's a standard, right? It's set to a standard so that you can always rely on it. However, with screws and nuts and bolts and bits and pieces and fittings and everything else that you'll likely run into in your R&D and product development, parts are done, they are not exact. In fact, just about anything in the store that you go to measure that is designed to be, let's say, a metric part, 10 millimeters, let's say, it's not going to be exactly 10 millimeters or 1 centimeter. It's going to be like 9.5 or 9.8 or 9.85 or something like that, right? So they're never going to be exact. So sometimes you have to literally, when you're measuring these things, you have to kind of round up a little bit. And that's with metrics, that's very common. With these bits and pieces, as you saw here, these were just a fraction under what they're supposed to be in their metrics world. So a 6 millimeter is actually 5.75 or something like that. It's kind of like when you go to the store and you buy a big box store and you buy a 2x4, right? It's not really 2 inches by 4 inches, it's like, I can't remember, it's like a 1.5 by 3.5 or something like that. You can comment below and let me know. I can't remember quite what that one is, but yeah, they're never quite exact, you know, but we round it up so that it's easier to talk about them, and it's roughly the size that we're talking about, so it's easy to conceptualize, okay, how can we use that part? But in fact, keep an eye on that. You know, keep in mind that these parts are not exactly what you think they are, so don't be fooled. Here's the other thing. And this is, I'm still trying to figure out this mystery, but in the world of NPT, this is really not 1/8 inch, 1/4 inch, 1/2 inch. I mean, there's absolutely nothing about this part. It measures 1/4 inch. The threads are way more than 1/4 inch. Now that the hose, the opening inside here for the air to pass through is approximately 1/4 inch, but it's approximately 1/4 inch on the 1/2 inch NPT too, and on the 1/8 inch NPT, right? So the air passage through is the same, capacity is the same, but the threads are absolutely not, and they're not what they say they are. So I don't know who came up with the NPT, the National Pipe Thread System, but it seems to me to be a little goofy, like all the other non-metric systems of the world are a little bit goofy. So I'm sticking with metrics. So caliper is another thing. If you don't have one of these, you really need to go on Amazon. Oops, forgot to mention, I'm not going to be mentioning any store names. Anyway, go to your favorite retailer, wherever you want to go. Buy them online or somewhere locally, wherever. I'm not sure who sells calipers locally, but give it a go. You probably box stores sell them as well. But really good ones are nice to have. This is an IP54 water resistant one, which is nice because sometimes I get caught out in the rain. This will resist rain. Don't let it sit out in the rain. It's not going to resist that, but it will resist some drops on it. Kind of nice. Measures in American and in metrics and in fractions of an inch and decimals of an inch. So really nice to have with me. I have it with me all the time, really. For measuring the original parts, for measuring and verifying tool sizes, for you know, when you get a mix and match part, you're trying to diagnose what the heck is this thing and how they measure it and what's going on. This often you can use your caliper to kind of figure out what's going on with a part. So get a pair of these. A nice one's probably, $30, $40 for a really nice one. Probably get a cheap one for $10. But at least have something digital, something nice like this that you can use on the fly for measuring these parts. So also hydroponics, aeroponics people, I don't know what your opinion about this would be from a purist standpoint of that world. I don't work exclusively in hydroponics, aeroponics, but it's one of the things that I work in. But I would say that, you know, given the choice, it looks like it's going towards a purely metric world for all of that too, the grow at home people. I see a lot of the products that are just measured in, for example, 6 millimeter versus 1/4 inch now. So I think metrics is becoming kind of standard for that whole world, but I don't know. Let me know in the comments. So there we covered that. Yep. Okay, I think we covered everything I wanted to cover for today. So that's a little bit more about threads. Let me know if you want to see any more on that. But while I have you here, wait a minute. I did say I was going to do a demo, so let me do that. All right. What do we have here? We have a 5. Yep, we have a 5, and we have a 5. Yep, we got it. Okay, so there we go. We've got, just verifying, M5, yep, M5, measure twice, cut once, as I think it was Norm Abrams on This Old House used to say. There we go. Okay, so that's a match set. That's an M5 drill and tap, and that is an M5 bolt. Yes? Good. All right, we agree. So take that out. I concur, doctor. All right, put this one in. Doctor, is that an M5 tap? Yes, doctor. Do you concur? Yes, doctor, I concur. Okay, here we go. Ready to go. It's locked in place. Now, you can use the clutch to adjust it so that you don't go tearing through. I've done this a whole bunch of times, so I just leave it on drill mode. unlimited power. But just go very slowly. Slowly. Straight. So you want it to be, again, you want it to be perpendicular to your piece this way and that way, right? So in all directions, it should be squared off to your piece, right? Every way, right? And then you go slowly. See that material swirling out there? Hopefully you can see that. Material's kind of those little squigglies there. Those are the things I was talking about earlier. When those get really, really big on a really big part, they're a force of nature. I mean, you can't get those out. It's impossible, which is why you need the backer plate back here, the metal one back here, so that when you put some oomph behind it, when you give it the beans, that when you go tearing through it, you don't go through the other side of your pipe. You have to hit something metal to stop it. That's how much craziness goes on with these pipes. Because it's sticky. Okay, now I'm through the drill part. Now I'm on the tapping part. I can feel it. The resistance just went up. So I'm putting a little pressure on, not much. You don't need much pressure with these because they're designed to, the drill is designed to immediately be followed by the tap and to go through easily. Now I'm going to back out. Okay, there's a lot of goop in there, right? Goop, that's a technical word. All right, back on. All right, blow that out. Gently, back in there, gently, get it started. Okay, good, keep going. All the way through. All the way through. All the way through, good. Then back. I feel like I'm talking myself through this. Very good, Andrew, very good, excellent. Not too much pressure, okay. All right. So now you have a hole tapped, clean, hopefully, we'll find out, and ready to accept its M5. Would you look at that? That's cool. That's a great feeling when you just like, I don't know why, it just is. When you drill that and you put those precision, quote unquote, precision threads cut in there and then you get that bolt in there, man, that's really cool. Because now it opens up a whole new world, you know. Once you can combine your metal parts with your plastic parts, then opens up a whole new world. All right, cool. As you can see, that just goes right through there, all the way in. Now, it's actually not what's going to be in there finally. I'm actually going to have an air fitting in there, so I'm actually going to tap that out a little bigger. But I just wanted to use this as a demonstration because it's a good material to demonstrate on. So there you go. If you're working with aeroponics, hydroponics, anything grow at home oriented, and you're working with a lot of PVC and you need to tap holes for various bits and pieces, that's how you do it. Let me know what you want to see down in the comments. Thanks for joining us today. And don't forget to like and subscribe. We hope to see you next time. Take care. Thanks.